consider this buck converter topology. Here we used one SPDT switch, single pole double throw switch, one inductor and one capacitor. Using one of each of these components, we can have two other configuration. So let us just take only those parts. See, Vi will be on the input side. The output side V0, we need to have a capacitor on the output side to get a filtered V0. So the capacitor will always be on the output side. So the position of the single pole double throw and the position of the inductor can change. However, note that the inductor current cannot be discontinuous. So the inductor cannot be on the throw side of the single pole double throw switch. If suppose the inductor was on throw 1 or throw 2, and whenever the pole was not connected to those throws, the current there would be 0 and the inductor current cannot go in a discontinuous way to 0. Therefore, it is also constrained that L has to be connected to the pole. So now with these constraints, we have two other positions where we can connect the single pole double throw switch and the inductor. So let us look at these two possibilities. So one possibility is to have the inductor on the input side. Flip this single pole double throw and the inductor. So if you do the flip, so you have the inductor first and then comes the single pole double throw switch like this. You have the input and the output. Capacitor is connected to the output, and to the input we have the unregulated DC input voltage, and to the output you connect the load like this and complete this single pole double throw switch connection. Now this is a single pole double throw switch L. This is a pole. This throw 1, throw 2, C, Vi, R0, V0 measured in this fashion, Vi measured in this fashion. This is IL. Now such a converter where inductor is on the input side and the single pole double throw switch is configured in this fashion is called a boost converter. Why it is called a boost converter will become evident shortly when we discuss the input-output relationship. V0 will always be greater than Vi. Therefore, it's called a boost converter. Then the other possibility, see in the buck converter, the inductor is onto the output side. In the boost converter, inductor is on the input side. One other possibility is to have the inductor connected to the ground. So let us do that possibility also. You have the single pole double throw switch in this fashion. We have the pole here, inductor connected to the pole and the other end connected to the ground. And the throw, one end of the throw connected to the input and the other end of the throw, other throw connected to the output. So complete the circuit in this fashion and you have the output Vi, R0, V0 and Vi, L, C. This is pole, throw 1 and throw 2. So this is called a buck boost converter. Why it is called a buck boost converter? Again, this will become evident when we derive the input-output relationship. V0 can be less than Vi or V0 can also be greater than Vi depending upon the value of the duty cycle. Therefore, this can do buck operation or even boost operation. Therefore, this converter is called buck boost converter. So you see, in the case of the buck converter, you have the inductor on the output side. In the case of the boost converter, you have the inductor on the input side. And in the case of the buck boost converter, the inductor is neither on the output nor on the output. It is in between, connected to ground. In all the cases, inductor is connected to the pole. Inductor is connected to the pole in the boost converter also. Inductor connected to the pole in the buck boost also. And the capacitor is to the output, connected across the output to filter the output voltage. So these are the three primary converters, the buck, the boost and the buck boost converters. They're called the primary converters.